Hey everyone, and welcome back. Ready for another deep dive?
Always ready to dive in.
Okay, excellent. So today we're all about SDLC solutions.
Ah, yes, the methodologies and frameworks. The stuff that makes software happen.
Right. It's funny, whenever I think about software development, my brain goes straight to lines of code and like people hunched over their computers at 3 a.m.
Yeah, the classic image, huh? Coffee fumes and energy drinks.
Totally. But obviously it's a lot more intricate than that, right?
Yeah.
Especially with all these different approaches and methodologies.
Absolutely. There's a whole world of strategy and planning behind those lines of code.
Yeah.
And that's where the SDLC comes in, right?
Exactly. The SDLC, full transparency, I always feel like I kind of get it, but also like maybe not fully.
Haha. Yeah, I think a lot of people feel that way. It can seem a bit abstract until you really start digging in.
So for our listeners who might be in the same boat, can we break it down a bit? Like SDLC stands for Software Development Life Cycle, but what does that actually mean in practice?
Sure. Think of it as a structured approach to building software, a roadmap, if you will. It's about taking a software project from a concept, just an idea, all the way to a finished product and making sure it's done right.
Okay, a roadmap. I like that. So what are the stops along the way? What are the phases of this SDLC roadmap?
Well, it typically starts with planning and analysis.
Ah, the foundation, right?
Exactly. This is where you define what you're building, why you're building it, who it's for, and what it needs to do. You gather requirements, you figure out if it's even feasible, you do all the groundwork.
It's kind of like making sure you have the right blueprints before you start building a house.
Perfect analogy. You don't want to start laying bricks without knowing how many rooms you need.
Exactly.
Okay.
Okay, so you've got your plan, you've analyzed everything. What's next on the SDLC roadmap?
Next up is design. This is where you create the blueprint for the software. You take those requirements and you start mapping out how the software will actually work. The user interface, the database structure, all of that.
Ah, so this is where it starts to take shape visually.
Yeah, you're starting to get a clearer picture of what the final product will look like and feel like.
Okay, so we've got the plan, the design, and then I'm guessing it's finally time to actually build the thing.
You got it. That's the development phase. This is where the coders take over and start bringing the design to life. They write the code, they build the features, they make it all work.
This is where the magic happens, huh?
Exactly. But the magic doesn't stop there.
Right.
Once the code is written, you have to make sure it actually works. So testing is crucial.
I was going to say, you can't just assume it all works perfectly the first time, right?
Definitely not. Testing is about finding and fixing bugs, making sure the software meets all the requirements, and ensuring it's user-friendly.
So does this mean like a whole team of people just clicking buttons and trying to break things?
Kind of. There are different types of testing, from unit testing, where you test individual pieces of code, to integration testing, where you test how different parts of the software work together, all the way to user acceptance testing, where actual users get their hands on it.
Oh, interesting. So it's a pretty thorough process.
It has to be. Quality is key, right? And then once you've tested everything and you're confident it's all working smoothly, you move on to deployment.
So this is where it goes live.
Yep. You release the software to the users. This could mean making it available for download, installing it on their systems, or making it accessible online.
Okay, and that's it, right? Mission accomplished.
Well, not quite. The journey doesn't end there. Even after the software is deployed, there's still ongoing maintenance.
Ah, right. Because software isn't just a set it and forget it kind of thing.
Exactly. You have to monitor the software, fix any bugs that pop up, release updates, and make sure it continues to meet the user's needs. It's an ongoing cycle.
So it's like a living, breathing thing.
Exactly. And that's the SDLC in a nutshell. A continuous cycle of planning, designing, building, testing, deploying, and maintaining.
Wow. Okay, that's a lot more comprehensive than I initially thought.
Right. But here's the thing. That's just the basic framework. There are also different methodologies or approaches to implementing the SDLC, different ways of organizing and managing the process.
Ah, right, like agile and waterfall. I've definitely heard those terms thrown around. What's the difference?
So waterfall is a more traditional approach. It's very linear, with each phase happening sequentially. You complete one phase, then you move on to the next. It's like a waterfall cascading down.
Makes sense. So what are the pros and cons of that?
Well, waterfall is great for projects with very clear, fixed requirements. If you know exactly what you need to build from the start and you don't anticipate many changes, waterfall can be very efficient. But it can be less flexible if things do change.
Okay, I see. So if you need more flexibility, you might go with agile.
Exactly. Agile is all about being iterative and adaptable. It breaks the project down into smaller chunks called sprints, and you work on one sprint at a time. You get feedback at the end of each sprint, and you can adjust the plan for the next sprint based on that feedback.
So it's more like a series of mini waterfalls.
Uh-huh. Kind of. The key is that it allows you to adapt to changes quickly.
That makes a lot of sense, especially in the world of software where things are constantly evolving. From your notes, it looks like Agile is the one you're leaning towards for your current project.
Yeah, I think it's a good fit. The requirements are still a bit fluid, and we need to be able to pivot quickly if things change.
Are there any other methodologies worth mentioning?
Absolutely. There's the spiral model, which is all about managing risk. It involves a lot of prototyping and risk assessment at each stage. And then there's the V-shaped model, which puts a strong emphasis on testing and verification at every phase.
Wow, so many options. How do you even choose the right one?
Honestly, it depends on the specific project. The complexity, the team size, the risk tolerance, the need for flexibility, all of those factors come into play.
It sounds like choosing the right methodology is almost as important as the SDLC itself.
Definitely. It can make or break a project. But there's another element that's become absolutely essential in modern software development, and that's security.
Oh yeah, that's a big one. You can't just build software and hope it's secure, right?
Absolutely not. Security has to be baked in from the start. And that's where the concept of DevSecOps comes in.
DevSecOps. That's a mouthful. What does that even mean?
It means integrating security into every phase of the SDLC. It's about shifting security left, so it's not an afterthought, but rather a core consideration throughout the entire process.
So not just bolting on security measures at the end.
Nope. It's about thinking about security from the very beginning, during the design phase, and incorporating security testing into every stage of development.
Give me some examples of what that looks like in practice.
Sure. So you might have automated security testing tools integrated into your development pipeline, so vulnerabilities are flagged early on. You might do threat modeling, where you try to anticipate potential threats and design defenses against them. And you'll definitely have security experts involved throughout the process, providing guidance and oversight.
That's like having a security guard at every checkpoint along the way.
Exactly. And it's not just about making the software more secure, it's also about making the development process more efficient and reducing the risk of costly security breaches down the line.
Okay, so we've talked about the phases of the SDLC, the different methodologies, and the importance of security. Are there any other key ingredients in this software development recipe?
Well, tools and technology play a huge role. There's a whole ecosystem of tools designed to support the SDLC.
Like what kind of tools?
Well, version control systems like Git are essential. They allow developers to track changes to the code, collaborate seamlessly, and revert back to previous versions if needed. It's like a time machine for your code.
That sounds super helpful, especially when you've got multiple people working on the same project.
Oh, absolutely. And then there are CI/CD tools, which stand for continuous integration and continuous deployment. These tools automate a lot of the build, test, and deployment processes, making the whole cycle much faster and more efficient.
So it's like having a robot assistant doing all the tedious tasks.
Exactly. And then you've got project management tools, which help with communication, task management, and keeping everyone on track.
It sounds like having the right tools can really make a difference in terms of efficiency and productivity.
Absolutely. It's all about streamlining the process and making it as smooth as possible.
Okay, so big picture, what are the key benefits of implementing these structured SDLC solutions? Why does it all matter?
Well, ultimately, it boils down to building better software. You get improved software quality because you're testing and iterating throughout the process. You reduce costs because you're catching errors early on and avoiding expensive rework later. And you improve communication and collaboration within the team, which leads to a more cohesive and efficient process.
So it's a win-win all around.
Pretty much, it's about making the software development process more predictable, more efficient, and more likely to produce a high-quality product that meets the user's needs.
So as we wrap up this deep dive, what's the key takeaway for our listeners? What's the so what of all this?
I think the biggest takeaway is that there's a lot more to software development than just writing code. It's a complex, multifaceted process that requires careful planning, thoughtful design, rigorous testing, and ongoing maintenance.
It's like a well-choreographed dance with a lot of moving parts.
Exactly. And understanding the SDLC, the different methodologies, and the tools and technologies involved gives you a much deeper appreciation for the work that goes into creating the software we use every day.
It's like peeking behind the curtain and seeing the magic happen.
Exactly. And it raises some interesting questions, too, like With technology evolving so rapidly, how will the SDLC need to adapt to keep up? How will it need to change to handle things like AI, the Internet of Things, and the growing demand for secure and resilient software? These are things worth thinking about as you continue to explore the world of software development.
That's a great question to leave our listeners with. It reminds us that this is an ever-evolving field, and there's always more to learn and discover.
Absolutely. The journey never ends.
So keep exploring, keep learning, and who knows, maybe you'll be the one shaping the future of software development.
Thanks for joining us on this